Okay, so as promised, we are beginning to talk about numeracy, specifically just talking about the structure of the number system. And today we're going to start off just with making sure we know how to classify numbers. And the numbers that we're going to be dealing with are called real numbers. Real numbers are nothing more than the numbers that you've grown used to working with. They're the numbers that you've learned to add, subtract, multiply, and divide with. Those numbers can be positive, they can be negative, they can be fractions, they can be decimals, okay? So they are all the numbers that you've grown used to. Now, why don't we just get a quick visual of what those numbers look like? Not the straightest of number lines, but there's a number line. I'm going to mark 0. Actually, I'm not even going to mark 0 on it, but I am going to put where 0 is going to be somewhere in the middle of the number line. Okay, so if you think about it, 0, as I mentioned, is right in the middle. And if we move to the right, we've got numbers like 1 and 2 and 3 and 4. And for that matter, let's stretch it out again. I'm just going to start this all over again. So we have a number line. Somewhere in the middle is roughly 0. And like I said, we have numbers like 0, 1, 2, 3, dot, dot, dot. Those are the numbers to the right. You notice those are all positive. And naturally, when we get to the left of 0, we start picking up negative numbers like -1, -2, -3, dot, dot, dot. But then there's all this space in the middle. Okay, so, between 1 and 2, there might be the number 1.5. Or between the numbers 2 and 3, there might be a number or something like 2.7. Notice one of these is a fraction, one of these is a decimal. Likewise, we could have numbers on the left side, say between 0 and -1. Maybe we have something like 0.3 repeating, okay? So this number line is actually made up of an infinite amount of numbers that we can fairly easily visualize, like the numbers in green, 0, 1, 2, 3, and so forth. The numbers on the left-hand side in red, -1, -2, -3, and continuing more negative. But then there's all these numbers squished in between. And we can keep cutting up those sections between those numbers we can visualize into smaller and smaller and smaller pieces. That's what gets us the fractions and gets us the decimals. So what we're beginning to see here is actually what the subsets are of the real number system otherwise. So let's start with the first subset, the whole numbers. The whole numbers are actually the numbers that you see already in green. Okay, and you notice a couple things about those. That first of all, they're only positive, but they do include 0, and there are no fractions, there are no decimals. Now, if we exclude 0, we would call all these other numbers, starting with 1, 1, 2, 3, 4, 5, and so forth. Those would be counting numbers. And the only thing we do to move from a counting number to a whole number is to add the digit of 0. Okay, so we're going to say that whole numbers are counting numbers. And 0. Now, what I like to do is to show this as a set of numbers. And the way mathematically we show a number set is to put a little bracket like that. So our first whole number is going to be 0, followed by 1 and 2 and 3 and 4, and then dot, dot, dot just means going on forever. Now, if you can't draw those brackets, don't get too concerned, okay? But just I want you to know mathematically, that's the symbolism for a set of numbers. If you ever saw this set of numbers and were asked to identify what it represents, you would be able to say that it is the set of whole numbers. And notice those are numbers, as I said, on the number line that start at 0 and are all positive to the right that we can count on the number line. Integers start with that whole group of numbers we've just established, and then it brings into the group all of the other numbers that jump to the other side that are opposites of those whole numbers, okay? So it's all those numbers in red to go along with all those numbers in green. So a simple definition for an integer is going to be all whole numbers and their opposites. Okay, so if I thought about that as a number set, I might start at negative, well, actually, I want to show that I can go infinitely, so I actually want to say dot, dot, dot. Let's just say -2, and as I work my way towards 0, I get a little bit bigger, -1, then 0, then 1, and 2, and 3, dot, dot, dot. Okay, those are all our integers. So it's all, whoops, keyword here, all whole numbers, from above, and building upon that by bringing their opposites. So we're now covering both sides of the number line, the positive side of the number line with whole numbers, and with integers, both the positive and negative side of the number line. The last thing we need to consider are the rational numbers. The rational numbers are basically all of those numbers up above and everything in between. And what we want to take into consideration is all of these numbers from above can be written as a fraction. Like I could think of 4 as 4 over 1, or an equivalent like 8 over 2. I could think of -2 as a fraction as -2 over 1, or an equivalent, say, like -12 over 6. Okay, so where I'm going with this is that the easy working definition of a rational number is any number that can be written as a fraction. So we go back up to our number line, we see some numbers that are fractions already. Okay, we saw actually 1.5. Okay, if we want to think about that as an improper fraction because that's a mixed number, that's 3 over 2. Okay, but 2.7 can be rewritten as 2 7/10, which can be rewritten as an improper fraction of 27/10. Notice that's a fraction, the numerator, the top number, over the denominator. -0.3 repeating. We should know that 0.3 repeating is 1/3. So in this case, it would be -1/3. So all of those can be rewritten as fractions. 3 can be written as, like I said, say 3 over 1, or an equivalent like 6 over 2. -2 can be rewritten like -2 over 1, or an equivalent like -12 over 6, and so on and so forth. So every number that can be converted to a fraction, and by that I mean a numerator or a denominator, would be classified as a rational number. Now, one really important thing for us to consider here, when it comes to decimals, this includes terminating decimals and repeating decimals. That's key, terminating and repeating decimals, okay? So looking back at our number line, a terminating decimal is something like 2.7. It terminates, it ends. It has a very clear ending to it. A repeating decimal is something like -0.3 repeating. It goes on forever. If we thought about that, it would be -0.333333333. We wouldn't have enough time in our lives to write all the threes that repeat because it never ends. Okay, so rational numbers are any number that can be written as a fraction that will always include integers and whole numbers. And if it's not a fraction already, if it's a decimal, it's those decimals that terminate or repeat. Okay, the last thing we're going to quickly do is we're going to kind of put this in visual form. So we're going to draw a Venn diagram. And that Venn diagram is going to have three circles. The first circle is going to be our whole numbers. I'm just going to use the abbreviation W, which you saw up above. That circle for whole numbers is inside a bigger circle, which represents our integers. And finally, those two circles are wrapped inside the biggest circle of all, which becomes our rational numbers, because all whole numbers are integers, all integers are rational. So the last thing you're going to do is take each of these numbers based on what we've just described for the subsets and place them accordingly in their circle. So I'll get you started. Just the number -8, I know is a counting number, but because it's a negative, -8 would go in my integers. So that one's already taken care of. So I want you to place all these other numbers, 3/4, 0, -3.4 with the 4 repeating and so forth. Just take all those and put them in the appropriate circles of your Venn diagram and be prepared to discuss when you come to class tomorrow.